In this example video, we're going to be looking at graphs that are periodic or maybe not. If they are periodic, we're then going to state the period that exists. I hope this isn't too blurry. I had to blow this up a little bit for the video. But essentially what we have here is a function that's going up, flat, coming back down, then going up, and flat, coming back down, going up, and flat, and so on and so forth. This function itself definitely is periodic. All of those y values are repeating. Here we're at 0, maybe we can call this 1, flat at 1, down to 0, back to 1, flat at 1, down to 0, and so on and so forth. We're not climbing or descending in y values. So this is totally periodic. We want to figure out the period. If we follow this point along on the graph, let's start here and see how long it takes to repeat all of the y values. So we're going to go up, flat, back down, up, flat, back down, up, flat, back down, and so on. So it appears that we have that common interval in between these. We want to find that distance. It doesn't matter which one you pick, they're all the same. If you went -2 to 2, the distance there would be 4. So we can list the period as being 4. In part B, we want to see if the y values are repeated. This looks like it has some kind of repetition, but you'll notice that the y values are kind of low here. They go up, back down, but then this point does not have the same value as this y. There's a difference here. That's an issue for us. If this function were periodic, we should come up with the same y value, back down to the same y value, and back up, and so on. And that's actually not happening here. So this function is not periodic. And we'll change the slide here for you. So we'll move over to this example, same example I guess, but C and D. So let's take a look at C here. This function, the y values appear to be repeated. So here we start down, we're up to this y value, back down to the same y value, and then back up to the same y value, back down to the same y value, and so on. This probably is one of those trigonometric curves, and I'm thinking right now that it could be well, sine, but it could also be cosine. We'll talk about that in a later video. But for right now, what we want to see is we want to see how what the interval is, or how often, what the distance is for the y values to repeat. So let's make a point right here at the origin. We'll follow this graph up, back down, and then we reach the point where the graph again goes up. So this distance right here is the period. Point of confusion for some folks is this part right here. So some folks say, oh, the shape is repeated. But we don't want to look at the shape for periodic functions. Yes, the shape will appear to be the same eventually, but we want to look at the y values themselves. This is a positive y value, this is a negative y value. And then we're back to the same spot here. So we want to list that entire period as being 2 pi. So yes, this is periodic, and the period is 2 pi. And you could write equals 2 pi or something like that, that's fine. Let's take a look at D over here. Kind of an interesting looking function. And for D here, it appears that the same shape is repeated, and also the same y values look to be repeated. The y values never go above this point, never go below this point either. So let's take a look and see if we can figure out the distance between where these things repeat. It doesn't really matter which part of the function you pick. It might be easier though to pick one of the peaks, or perhaps maybe a value that's easy to read off the graph. Let's just choose this value that's easy to read off the graph. This is -1 and this is -2. So let's see how long it takes for this thing to repeat. So we're going to come down and then back up, and then this point, this segment is the same right here. So it looks like from here to here, that's our period. If that's -2 and that's 2, it looks like this has a distance of 4. So this one is periodic, and the period is 4. We've got a couple more to do. Just 2 more for this example. And hopefully I can get you an example on the screen. My goodness. So we've got E and F. E, it looks like things are being repeated, but you'll notice that the Y values here are getting lower and lower, and here they're getting higher and higher. So even though it seems like a certain shape is being repeated, it looks kind of like a spring or something like that, this one is not periodic. It's not periodic because the Y values are not repeating. Here the Y value is close to 1, and then over here we got something like 0.35 or something like that, and then 0.2 and so on and so forth. So what we would need is we would need for this function to reach the top point at every single period and then keep going. So because these Y values decrease and then here they increase, this one's not periodic. Not sure how this one showed up on the notes, but this one is, I'll just trace this for you if you want so you can really see it on the video. But this looks like either a sine or a cosine curve. It's got a nice easy wave to it, and things keep coming up and down. I just thought of another application of this, which is electricity. So if you're looking for applications of these things, they are numerous. Daylight hours work, tidal waves work, all sorts of stuff in nature is periodic, like these sine and cosine curves. So here we have a function that appears to be repeating, and the Y values don't change. So here's a Y value of 1, we come down to 0, down to -1, and then back up to 1. In contrast to this one where they were going down or coming up. So we want to take a look at how often this thing repeats. That's the period. Let's choose this point right here. So here we're at 0, we go up to 1, back to 0, but here we have a -1, and then back up to 0. So the period is going to be between 0 and 2 pi. So we can say that this one is periodic, and the period is 2 pi.